Hi, we're at Itron Utility Week and we're capturing the last of the 3 Itron demos. So we've done gas, water, and we're now at electricity. We're going to skip the first half of it because there's another video that we did where we captured this demo, and Kevin here is going to show us the other use case, and I think we need to move on over a little bit, so it's over here, right?
So actually the story involves 3 homes on a street, and so we have 3 residences, 3 meters, we have 3 load boxes that are representing refrigerators, AC units coming on and off inside the home. We have a transformer that's one source of power. It's rated at 310 VA for our demo, and we have 3 meters that have load. So let me get that in a static point because we want to see the load rising as people come.
You want to see fluctuation.
We don't want to see fluctuation because we want to track that encroachment upon 310.
Okay.
So right now we've got each meter recognizing its individual load. 31 watts here. We've got about 5 watts here. And then they're also communicating with peer-to-peer communications, the community's summation. So they're adding up them all. And we have community load of 61 watts for the whole street.
Okay, so let me replay that. You see each individual meter, but within the meter you also see the community load.
Right.
So you're saying this street of 3 houses in aggregate is at 61%.
68 watts.
68,
yeah.
Right, yeah.
So we're well under our transformers rating right now.
Right.
Everything is hunky-dory.
Right.
So this neighbor comes home from work and turns on the lights, the TV gets comfortable for the evening, and they've increased their individual load, of course, and the community value has increased, and as we can see on all the meter faces.
So that individual load is now 59, if I'm reading that right,
Correct.
right? And the community one is 119.
Right.
Right, okay.
And it's being shown on the other meter displays because they're communicating that value and keeping in sync with each other. So they all know that we're about at 120 watt now.
So are we going to try and break this now?
We're going to break it.
Right.
Yeah,
Cool.
we're going to get it real interesting here in 1 second. So this guy comes home, turns the electric stove on, and begins cooking dinner. So we're increasing again an individual here, but the community value is now at, let's see, 212.
Yep.
And that's going to sync over. They're all going to be in sync. There's 212 there. So we're still communicating. We still are in sync. Still well under 310. All right, now, this box is plastic because I have a Wi-Fi switch inside of here.
Right.
And it represents an electrical vehicle charging station that has a Wi-Fi disconnect switch. Now,
Right.
whether by regulation or incentive, this customer is given the utility permission to be able to control it.
Right.
So, he's charging his vehicle. He wants to get to work in the morning, and everything's fine. So let's look. What are we at? Individual of 80?
80.
And
234.
234 watts.
Yeah.
All right. 310 is our number we're looking for. I'll go ahead and ruin the suspense.
Right.
This guy comes home, adds some more load to the street. Now watch. Our light here, it's red, it's lit, the car's charging. And as they assemble a new value, they realize they've exceeded the threshold of the transformer.
Something's just tripped, right?
It's just tripped.
You've turned the car off.
The car's not charging anymore.
Right.
Because we were causing loss of life on our transformer.
Yeah.
The meters have now disabled that car that's charging in the garage.
And because that was in this scenario, it's a permission-based thing. Say, hey, you can turn my car off.
Right.
As long as you make sure it's got enough charge in the morning. I don't care when you're turning it on and
That's
off.
right.
So this man steps out of the shower, goes back down, we start charging again.
See, you've done
right?
this demo before. All right, so let's do that. So they finish dinner or they get out of the shower, turn the stove off. Now we have enough headroom, perhaps. They're recalculating the situation, and once they've decided that there's headroom for this load to be re-engaged, car's charging again, he can get to work in the morning. He might never have known that happens. We can tweak the code and send alerts to the back office, so they could even text their customer and inform him of the inconvenience. And more importantly, what if this happens 30 times in a week on a street? We'll send statistics to the analytics department in the back office to say maybe we need to prioritize an upgrade on this transformer.
Right, and how important is it for this sort of activity to happen at the edge rather than being pulled back to a command and control system and pushed back in again?
Right, so think how many streets you have in your territory, how many communities are under different transformers. Really, it's only possible at the edge when we have computing power that's regulating itself and not the latency of going to the back office and then having permission sent back. We're in real time here. We could have more loads that we could just turn on and off. This is a simple example, and a round robin could be in place. It's just proof of concept of really an incredible opportunity.
And then while we're here, is that box over there one more thing we want to talk about?
Yeah, let's take a look at it. So this is a cap bank controller. It's a distribution automation device. It's sort of an older model. It doesn't know anything about Riva or meshes or IPv6. But we've made it smarter with our Riva DA gateway here. Now, this is running a special application that is speaking Modbus protocol. And that's not a metering protocol. It's specific to this class of device. And so we can command it. We can, from the back office, issue requests for information through that gateway. We're getting the voltage back every second. We're checking the switch state. And the idea is that we want to be able to make this device smarter and reach it from the back office, but we want to go one step further.
Right.
Let's look at this meter over here. This is a perfect candidate to be a bellwether meter. He's at the end of the line. He's going to be suffering the worst voltage problems. And so he's a great sensor to check for voltage. Let me go ahead and turn some load off. Let's get our load back down to our volts to 240 just for the demo. Now, he's got an app that's running and reading that 1 second data off of the metrology, and he's checking for voltage. He's programmed to ask for help to that cap bank controller when his voltage sags below a certain threshold.
Right. So that then maintains the quality and frequency control.
It releases the charge onto the line and restores voltage when there's a suffrage. So I have a Variac here. It's powering the whole board. Everything's powered and plugged right into this thing. And I'm going to drop the voltage down to 205. So let's turn this down. We see the voltage is dropped. And over here, when that realizes it's fallen below threshold and needs help to restore proper quality, it sends a command over to our DA gateway, but then through Modbus, a legacy sort of DA kind of protocol, tells it to close in. And then we get a status update in the back office. I restore the voltage with the Variac, and it opens back. And it's just automated. Again, another example of edge intelligence without any back office permission or.
And listen, we know how hard it is to put something like this in a trade show environment, and the wireless and the controllers have been going up and down, but that's been great. Thanks so much for taking the time to demo, and thank you very much for watching. We just wanted to capture some of these live use cases that are being shown here at the event, and we got to stop because everybody's breaking down and the show is finished. Thanks again for watching.